How does Huygens' principle relate to refraction? We have to remember that Huygens' principle states that every point on a wavefront acts as a point source. In refraction, as the wavelets propagate from each point, they propagate more slowly, causing a bend. This effect is apparent when you put a spoon in a glass of water. Since light is traveling on the fastest path, it comes in at an angle, causing a bend in the wavelength. This effect can also be seen when driving on a hot day. The rise in heat causes the wavelets to travel faster. What looks like a puddle on the ground is actually a reflection of the car.
So basically, Huygens' principle is there's waves like this that are wavefronts, right? And on the wavefronts, there's points. And each point on the wavefront is a source of spherical waves. So if there's a barrier here that blocks the sound wave, right? I mean, it keeps going, and there's a point right here. And that point is a source for a new spherical wave. It goes like this. So right here is where you could see Huygens' principle in action, and you can further see this if, like, say there's another barrier right here, and this is the opening, and there's a new point right here. There's spherical waves that go like this. So you can see this as like in ocean waves. This would be like the wavefront, the barrier, and the point would be right here, and you can see the diffraction right here.
Here is an example of Young's double slit experiment. We will be using a barrier with holes that are so small that we refer to them as slits. And we're using a barrier with 2 slits. Using common sense, one would think that with the light shining through the double slits of the barrier, it would project 2 distinct spots on the wall. However, this is not the case. The light waves don't travel straight through the hole, and instead they diffract or spread out, and with the 2 holes, the waves will interfere and overlap. The waves can interfere constructively into a bright spot or destructively into a dark spot. We can actually use geometry to find the conditions for constructive and deconstructive interference. So we have one formula for constructive interference, which is bright, and another for destructive interference, which is dark. So basically, Thomas Young's double slit experiment showed how light diffracts through a slit. And with 2 slits, the light waves will interfere, causing constructive bright spots or destructive dark spots.
We're going to start a problem using Young's double slit equation. The problem is the light of a wavelength is 800 nanometers and it shines through a double split where holes are 300 nanometers wide and are spaced 1400 nanometers apart. If a screen is placed 4 meters away, what will be the distance from the central bright spot on the screen to the next bright spot? We have the double slit formula, which is d sine theta equals m times wavelength. Theta is the wavelength, the distance between the peaks. M is usually 0, 1, or 2, etc. It's the order. And d is the distance between the 2 slits. And theta is the angle from centerline up to the constructive point at the wall. Now we have to keep in mind that the width of the wavelengths do not play a part in this equation. We just have to make sure that they have a wide enough angle of diffraction. With the information that we have, we can start plugging things into the equation. We know that the slits are 1400 nanometers apart, which is d. And we know that m is 1 because we're going from the center line to the first order constructive point. And lastly, the wavelength we know is already 800 nanometers. With the equation plugged in, it would be 1400 nanometers sine theta equals 1 times 800 nanometers. In order to find the distance, we have to first find the angle. So we're trying to get theta, or the angle, by itself, and it comes out to be 34.8 degrees. Now we can use the angle that we found to get the distance between the centerline at the wall in the first order, which I'm going to call delta y. Using trigonometry, we can find the distance that we want with the help of tan, the angle that we found, and the distance between the slits and the screen that were already given to us. Next, we just have to get delta y by itself, and the equation would be 4 times tan 34.8 degrees, and it would come out to 2.78.